Let's begin today on Chapter 10, starting with Section 10.1, which is our graphing and our understanding of functions, domains, and ranges. So we're going to begin first with a definition of what a function is. According to our textbook, they state the following: a function is a rule that assigns to each element from one set exactly one element from another set. So what does this mean? It means for every x value, there is only one y value. In other words, x does not have more than one output. So 1. And this defines what we need to know about a function. All right. Now, the thing about a function, it has a description of domain, all the independent values, usually x, that describe where the function, can't spell, sorry, where the function exists. That's a domain. And the range is the outputs. Of the values. In this case, it's x, the independent values, which are the x values, and the output is the y values. Now, here's how the description is said in the textbook. The set of all possible values of the independent variable in the function is called the domain. The resulting set of possible values of the dependent variable is called the range. So in our range, we're saying all the outputs. So here we have an example. And this one introduces some information we should know. And we're talking about inequalities. All right. So the first thing is that we have this symbol here. All right. In this case, it's read as square root. Square root, we know that we have to have a value that is non-negative. Because otherwise we have what's known as an imaginary. And we don't do imaginaries, we're in the set of real numbers. All right, so what we're saying here is the fact that if we have the square root of 25, we know it is a 5. And it can be a plus or minus 5, because the square of that will give us 25 if we're looking for solutions. So here we go on this scenario here. Okay, so in this case we have an inequality because we know that it is an x squared. We're going to state that dividend, the inside, has to be greater than or equal to 0. All right. So the other thing that we have to know about inequalities is the fact if we multiply or divide by a negative value, the inequality symbol changes directions. And we're going to have that scenario right here. Right. So let's look at our process here. I'm going to say 144 minus x squared has to be greater than or equal to 0. So I'm going to subtract the 144. Now subtraction does not flip the symbol, only multiply or divide. Negative x squared has to be greater than or equal to a negative 144. Now I'm going to divide by that negative 1 so that x squared is, flip it, right, a positive 144. So now to solve, we would take the square root. And of course, x has to be less than or equal to 12, and it's a plus or minus. So now we have two outputs, two parameters, I should say. So this brings about the concept of the number line. We know here is negative infinity, and here is positive infinity. And if this is 0, we'll say this is negative 12, and this is positive 12. So we're going to now test our domain. In other words, what makes it true? So I'm going to use a number, right? So I'm going to use 0. So I'm going to have the square root of 144 minus 0 squared. So that gives me 12, because that's 144. So that works. So let's try one outside of that area. Let's try f of negative 13. Well, we get the square root of 144 minus, in parentheses, negative 13 squared. Sorry about that. We know we square anything, it's a positive. So I'm going to have f of negative 13 is equal to the square root of 144 minus 169. Well, this gives me a negative, right? Of negative, what is that? A 5 and a 2. 5, and that, if I did the math right, let me check on that. Yes, I got it right. So, okay. So this is true. Well, this is a negative, and we can't take the square number because it's imaginary, so it's outside of the realm. So this means that this does not work, and of course 13 over here would not work. So our domain is negative 12, comma 12. Now what did I write that in? We're going to talk about this structure right here is brackets around negative 12 and 12 because it can include those endpoints. This is called interval notation. Hey, so we're reviewing a lot of math in that one figure. Now they wanted See what else they wanted. All right. So they wanted domain of the function, and we gave it the domain. All right. Now we're talking about mapping. Mapping is to have X set of values on the left set of values on the right. An arrow output on. Okay, what do we want to do then? We want to figure if it is a function. In other words, only one output for each input. Right. So we're going to write our output. If I get a 13 input, I get a 23 output. And I see only one arrow to one number. So that is correct. Then I have the number 4, and it maps to 9. And that is good. There's not 2 4s and there's not 2 13s. Then I have 16, and it maps to 23. Even though the outputs match, the inputs are not repeated. Therefore, what can we say? Therefore, that's the 3 dots like in a triangle. Therefore, it is a function by definition on output and input. Now we're talking about another form of determining a function. This one, we're using something called the vertical line test. Vertical means up and down. So that means a visual approach to X value on Y value. All right. And a graph, of course, is the X and Y. Right here we have a parabola. Okay, so if I draw some lines, oops, sorry, I did it kind of, and I was using this so it wouldn't be crooked, and it is. Sorry about that. Let me cut that. So I'm going to do it by hand. Sorry. Made a mess of that. So if I draw a line, I see there is only one X value in any point. Okay, only one for each X. Therefore, this passes line test. Is a function. Right. Now, this one is a circle. So if I did that one, you can see that it has many points that are values of X. I assume I drew this very straight. So this one is not a function. X values have some dual two of them, y values. Therefore, it's not a function. All right, moving right along. Now we're talking about looking at ordered pairs. Again, we want to ensure the paired relationships have no duplication of x's. All right. So notice here's my x's. Okay, this is where I'm looking. And I'm checking to see if there's any duplication of x's within it. No, there are none. So all the outputs are immaterial because they can all be the same number. But there is no repetition of x values. Therefore, the ordered pairs right. Excellent, 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 right? All right. So we know that 7, 4, 1, 0, -1, -4, -7 are my x values, and it doesn't matter if we have the same y values. Even though these two match, it does not interfere with them being a function. Talking about evaluating functions. A function is in the form of y equals or f of x equals. And we're inserting, find the ordered pairs containing the given implementation of values. All right. So, and then we want to graph the ordered pairs. All right. So what we have here is a set of values. So I'm going to say y equals, and my first one, a -1 plus 3. Well, this will give me a -1 times 2, which is a -2. So that means my ordered pair is a -1, -2. All right, that takes care of that number. Now I'm going to do 0. Y equals 0, parentheses, 0 plus 3. Well, this is 0 times 3, which is 0. So this is 0, 0. It goes to the origin. Now we're going to do the third one, is a 1. Y equals 1, parenthesis, 1 plus 3. That's 1 plus 4. So y is 4. All right. Checking my math, making sure I haven't made an error, and I haven't. So now I'm doing the next one, and the next one is a 2. Y equals 2, parenthesis, 2 plus 3. 2 times the 5 is going to be 10. So I'm now to my third. See, here's the 1, the 2, the 0, -1. I'm in the third. Y equals 3, parenthesis, 3 plus 3. So I have 3 times 6. Now they're getting very large, aren't they? 18. my ordered pair is 3 and 18. And right along. Now I'm going to have the last one, y equals 4 times 4 plus 3, 4 times 7, y equals 28. All right. Now, on the computer, you will be given the graph. And I did not insert one, so I'm going to draw a more or less, because we're going to plot all of these points. All right. Let's see if I can do that. So we want a -1, and it is a -2. Right down, oops, sorry, right down here. Sorry about that. It's a -2. Then I have a 0, 0. And then at 1, I have a 4. And I'm going to make this a 4. I may not go all the way to the top, but you'll get the idea. So 1 is a 4. A 2 is a 10. 2, 4, 6, 8, 10. Right? So at a 2, I have a 10. At a 3, I have an 18. I'm sorry, it just goes way up there. Okay, so that's 10, 12, 14, 16, 18. It's right there. So what I have is this. But it didn't ask us to draw a line. It asked to plot the points. So all you're going to do is click on the points, not draw the line, but it's part of a parabola. But I think it does. I don't remember. Okay, but if it wants the line, it'll automatically do it. There is a feature on it. I just don't remember which one they wanted. So this one says substitution. So now we're talking about substitution. Substitution is a big math concept where we replace the variable x with given. Oh, sorry about that. Value. Here we always have either an f of x, and then we want to change it to f of x plus 2 or something. Or in this case, we have a g of x that we're changing. Everywhere there's an x, an r, g of r plus h. All right. Now, this is not hard, and in this section, not meant to convert or do the math afterwards. Now remember, this is our function, g of x equals that. So I'm going to write it in green. And we want to substitute. What we want is g of r plus h. So this would mean, in parentheses, r plus h squared, the square outside of the argument that we're adding, minus 4 parenthesis r plus h plus 3. And this is the solution for substitution. You don't have to simplify. A future section. All right. Very easy to do. All you're doing is substituting r plus h everywhere x appears. That's what you did in the function for x. Only in 2 places, but you include the constant 3 to the mix. Here we go. Now we have this one. And this one has to do with a future analysis, and that is the difference quotient. So we have this quadratic, 2x squared minus 5x plus 6, and they want us to substitute f of x plus h into the function. All right, so to do that, we're going to say f of x plus h equals 2 parentheses. Notice the 2 is a multiplier, not part of the argument x. X plus h squared minus 5x plus h, parenthesis, plus the 6, and I'm done. On the B, they want f of x plus h minus f of x. What they're doing is a compound change of this function, but they're not changing this one, but we have to include it because this is a compound functional change. So what I'm going to write is I'm going to write 2x plus h squared minus 5x plus h plus 6 minus, and in parentheses, I'm going to put my original function, 2x squared minus 5x plus 6. Again, we're getting used to reading what a functional change is and arguments want us to do. So this is the answer. You do nothing more than that. Now our C says they want the whole argument above over h of x plus h minus f of x all over h. So this means we write what we just did, so you'll see the answers. So we're going to write, this is our last entry, 2 parenthesis x plus h squared minus the 5x plus h plus 6 minus the 2x squared minus the 5x plus 6, the entire thing divided by h. And that finishes that problem. All right. So now we're testing for even and odd. Fold it, can fold. At origin, and get the same thing, or wherever it's shifted. Odd means we have to rotate it. And get the same function. All right. Well, what this means to us is that we mathematically, let me make some room. Substitution of x, of negative x for x in the function. Evaluate the change. Sorry about that. And there are 3 conditions. One is if I substitute a negative x and get the original function, then it is even. If I substitute a negative x for every x in the function, and I get every sign change, have an odd function. We have f of x, negative x, and there is some changes. It's neither. Okay. And that occurs sometimes in some of the functions that we do. All right, so we have some here. This is a linear function, degree 1. So I'm going to test it. F of negative x is negative 7 times a negative x. Well, a negative times a negative is a positive. So the function at a negative x changes from a negative to a positive. Therefore, it is odd function. All right. So we're going to classify this one. All right. So we're going to do f of negative x. That'll give us a 7 over negative x squared plus 4. Well, we said any negative squared is a positive, so I'm going to have 7 over x squared plus 4. No changes. Therefore, it is an even function. Okay, I've been talking for 30 minutes, so I'm going to stop right here, and we're going to do our application problem last. And it's not difficult, and you're going to do just fine. Okay, thank you very much for listening.